Today we're going to be talking about special products with factoring, square numbers, and cube numbers. A square number has an exponent of 2. Over to the left of the screen you'll see some perfect squares. Basically you will either have a binomial or trinomial that has perfect squares. With a binomial you may see the difference of two squares. You will always use different signs to factor because the 81 is negative. Notice 81 is 9 times 9. Positive 9 times negative 9 is equal to 81. Then also the 16 in the front is a perfect square number as it's 4 times 4. So I will place 4 and 4 in the first position of each parentheses. Now normally you will have an x squared or y squared. In this case you have y to the fourth, and y to the fourth is simply y squared times y squared. That's how to factor the difference of two squares. Now if you have a trinomial and it is a perfect square trinomial, it will look like one of the following questions. Look at the signs. If they're all positive, then you will use the same signs, positive and positive. Since the first term is x squared, I have x times x. And the last number is 25, which is 5 times 5. Now this can also be written as x plus 5 quantity squared. Then if you have the second situation where there's a negative middle sign, then you still use the same signs, but they'll both be negative. I have x times x is x squared. 64 is 8 times 8. And again, this could also be written as x minus 8 quantity squared. And that's how you work perfect square numbers. Now, if you have a cube numbers have an exponent of 3. It's like a triple of that number. For instance, if you take 3 to the third power and you multiply 3 3's together, you get 27. Now when you have a cube, it will always be a binomial. And you can set this up as a short parentheses and a long parentheses, remembering the word SOAP. The abbreviation SOAP stands for same sign, opposite sign, and always positive. You will place these signs into the place, so that'd be a positive like the original, a negative, and then a positive. Then you break apart your cubes. X cubed, or x to the third, is really 3 x's multiplied together. The first x will be placed in the first shorter parentheses. The other 2 x's will be multiplied together, and they will be placed as x squared in the second longer parentheses. Then we break down our 8. 8 is really 2 times 2 times 2. The first factor of 2 will go in the first parenthesis, the shorter one. The other two 2's will get multiplied together to give you 4, and they will be placed in the rear of the larger parentheses. When that has been complete, you will notice there is a missing spot in the middle of the second parentheses. That will always be the first two terms, x times 2 in this case, multiplied together. So my final factorization is x plus 2 times x squared minus 2x plus 4. Now let's look at this in a second example. I have a short parentheses and a long parentheses. I write the word SOAP. S stands for the same sign as the original. O is opposite of the first one, and AP is always positive. Now this time we have an 8 in the front with an x cubed, so that means 2x times 2x times 2x. The first 2x goes in the first parentheses. The other two 2x's get multiplied together to give us 4x squared. That will go in the second longer parentheses. Then I will break down the 27, which is 3 times 3 times 3. The first 3 will go into the first shorter parentheses. The other 2 factors of 3 multiply together to give me 9, and they go in the second longer parentheses. Then last but not least, I take the items in the first parenthesis without that sign, 2x times 3, which gives me 6x, and that's my middle term. The final factorization is 2x minus 3, and then 4x squared plus 6x plus 9.